Hello students, welcome back. Welcome to the TSPSC preparation strategy for Polytechnic lectures, and the subject is power systems, and in power systems we are going to discuss about the faults and stability and the load flow analysis topic here, right? So welcome to AS online students and AS Engineering Academy. Here we are going to discuss about the power systems, faults and stability preparation strategy for the Polytechnic lectures. So see here students, this is the actual syllabus of power system. So in the actual syllabus, generation is there, transmission and distribution of electrical energy, power system analysis is there, and switchgear and protection and utilization of electrical energy we are having in the syllabus of the Polytechnic lecturer students. So today we are going to discuss about the power system analysis concept, in which we are going to discuss about the problems related to or concepts related to the fault analysis, stability analysis and load flow analysis concepts, right? Now, so what they have given the syllabus, this is the prescribed syllabus given for Polytechnic lecture students. So they have given per unit quantities and bus impedance matrix and bus admittance matrix, load flow studies, symmetrical components, the total is related to the fault analysis and power system stability analysis related concepts, right? This is the syllabus given by the prescribed TSPSC authorities, and the weightage analysis already we have seen in the TSSPSC-EEE preparation strategy. So these are the marks we are going to expect, right? So 21, 18, 22, 29, 22, 16 and 16 are the marks we are having for power systems, right? Sometimes they may be increasing for 20, sometimes we are getting more than 15. So between 15 to 20 we can expect the weightage for the power systems, the entire power systems, right? Now, so this is the syllabus of the power system students. So power system analysis, not power system total, it is the syllabus of power system analysis, we can say. So first of all, we have to study about the basics of the balanced power systems. In the basics of balanced power systems, we have to study about the basics of single phase power transmission and basics of balanced three phase power transmission system, right? So try to understand balanced three phase power system clearly. When balanced three phase power system is clear for you, then we can go for basics of unbalanced three phase power system we can serve, right? So that in chapter 1 we are studying about basics of balanced power systems in three phase, and basics of unbalanced power systems we are studying in chapter 5. And in chapter 2 we are seeing the representation of power system network in per unit system, right? So as we are facing some problems in the actual absolute system of analysis, we are moving it to per unit system representation. And later on we are going for matrix representation of power system, where we are studying about bus admittance matrix formation and bus impedance matrix formation. And next we are studying the load flow analysis concept. And next one, basics of unbalanced power system we are studying. There we are introducing about the symmetrical component theory. So after introducing symmetrical component theory, so we are studying symmetrical network construction for the entire unbalanced power system network. So later on we are going for the fault analysis, and later on we are going for the power system stability analysis. So see here students, per unit system and chapter 1 and chapter 2 are basics for entire syllabus. So try to understand basics of balanced power system and the per unit system representation. They are very basics for entire syllabus. And matrix representation is particularly preferable for load flow analysis. So that is particularly Y bus is preferable for load flow analysis. In that Z bus is particularly preferable for understanding the fault analysis, right? We can do Z bus based fault analysis. And chapters 5 and chapter 6 we are studying to understand chapter 7, right? So without understanding chapter 5 and chapter 6, we are unable to go to chapter 7. And finally, power system stability analysis, where we are studying steady state stability analysis as well as the transient stability analysis and equal area criteria related concepts, right? Now, so as we are discussing every time, what are the textbooks we can prefer? So if you want to learn the subjects clearly, we can take, these are the textbooks. So power systems, right, by power system analysis by Stevenson and Greiger, and electric power systems by John Wheely publications, and we can take Duncan Glover and DP Kothari and Ajay Nagrat. And some for practice questions for local state government exams, we can take JB Gupta and CL Vadhwa. We can take these two textbooks for more practice questions. Clear, students? So these are the textbooks we can prefer. And what we have to practice? So we have to practice previous ESC questions, objective, right? Conventional questions, right? And PSC questions like ISRO, DRDO, and we are having BARC, ONGC, like that we are having some PSUs. Try to practice those questions. And previous gate 1 mark questions and previous state board questions of like TSPSC, TSSPDCL, TSNPDCL, right? All those question papers, try to practice them. And previous SSC JE and RRB JE questions, right? This is the practice set you have to maintain. Along with that, try to maintain JB Gupta. So try to practice those questions, right? To get maximum marks in the competitive exams like this, right? First of all, we'll see some questions related to the per unit system analysis. Per unit system analysis. Try to solve this question, students. A transformer is having a transformation ratio of K. Then Z01 per unit is equivalent to Z02 per unit. When it is possible. A transformer is having transformation ratio of K. Then to have Z01 per unit is equivalent to Z02 per unit. Then what are the conditions to be satisfied? Right? Try to solve that one. Try to solve that question, students. I am expecting the answer from you. Good evening, Ram Tulsi, Durgam, and Anita. Good evening. Any answers? Any answers? Can we expect? Durga Prasad, Anita. A transformer is having a transformation ratio of K. Then Z01 per unit is equivalent to Z02 per unit. When it is possible? So aspirant is given option B. Very good. Very good. Very fast. Very fast. Very good. Durga Prasad Chari. So V2 base is equivalent to V1 base and S2 base is equivalent to S1 base. Jagtap is given option D. V2 base is equivalent to V1 base by K square. So it's one of the easiest questions, students. Please look at the solution. Please check here. So see here, students, for a transformer, on primary side, the base quantities are V1 base and I1 base and Z1 base and S1 base are the base quantities on the primary side. And on secondary side, V2 base, I2 base, Z2 base and S2 base are the base quantities on the secondary side, right? So V1 and V2 are related with the transformation ratio K, right? Suppose the transformation ratio of the transformer is K, then to maintain the voltage basis, so V2 base should be equivalent to K times of V1 base. V2 base should be equivalent to V1 base, right? So we check here. So where V2 base is equivalent to V1 base. So V2 base is equivalent to V1 base. And also the power base, S1 base on primary side and S2 base on secondary side should be exactly equal. The transformer will not have two different power bases. So V1 I1 is equivalent to V2 I2, or V1 I1 base or V1 base into I1 base must be equivalent to V2 base into I2 base. Therefore, S1 base must be equivalent to S2 base or S2 base must be equivalent to S1 base. So that the correct answer is option B. So V2 base is equivalent to K times of V1 base and S2 base is equivalent to S1 base. Please check it. Please check it. Yes. If you want to maintain K is equivalent to 1, if you want to get K is equivalent to 1 in per unit quantities, then you have to maintain these as the base quantities. So otherwise K will not be equivalent to 1. Durga Prasad Chari. Durga Prasad. So if you want to get K is equivalent to 1 in per unit quantities, the base quantity should be maintained like this. If the base quantities are not maintained like this, it's not possible to get K is equivalent to 1 in the resultant per unit system. Resultant per unit system. I think it's clear for you. So we are going for the next question. Try to understand the next question, students. Right. The next question here. So this is the next question. Try to solve this question, students. We are having 11 kV generator and we are having a transformer 10 kV bar 220 kV, and in between we are having transmission line, and one more transformer is there 121 kV bar 11 kV, and the load is connected here. In the single line diagram shown above, if the base voltage for the generator is 11 kilovolts, then what is the base voltage for load connected at the bus 4? What is the base voltage for the load connected at bus 4? Try to calculate that one. Try to calculate that one. So we are having in the single line diagram shown above, if the base voltage for generator, if generator is having a base voltage of 11 kilovolts, what is the base voltage for the load they are asking? So try to understand. Try to understand. Try to understand the question. Any answer? Any answer? Try to solve it. Try to solve it. So the generator is given 11 kilovolts and its base voltage is also 11 kilovolts. Then what is the base voltage for the load connected at bus 4? Load connected at bus 4. Check here, students. We can divide this network into different zones. This will be zone 1, right? And up to here it will be zone 2, and here I have zone 3, right? We are having zone 1, zone 2 and zone 3. Zone 1 is having a V1 base. In zone 1 we are having V1 base new value, and in zone 2 we are having V2 base new value, and in zone 3 we are having V3 base new value. V3 base new value. So V1 base new is in zone 1, V2 base new is in zone 2, V3 base new is in zone 3. So what is V1 base new is given? It is given that they are given 11 kilovolts as the base voltage. It is 11 kilovolts as the base voltage in zone 1. Then what is V2 base? What is V2 base? V2 base should be K times of V1 base new value. K times of V1 base new value. Therefore, V2 base new value is equivalent to what is K? K will be given by the transformation ratio of the transformer. What is transformation ratio of transformer? It will be 220 kilovolts divided by 11 kilovolts into 220 divided by 10. It's not 11. It will be 220 divided by 10 kilovolts into 11 kilovolts. So that you can write 22 into 11. 22 into 11 kilovolts. 22 into 11 kilovolts is the base voltage in the zone 2. What is the base voltage in zone 3? The base voltage in zone 3, it will be K times of V2 base new value. Check here. In zone 3, if you want to calculate the base voltage, that will be K times of V2 base new value. So what is K value? K value will be given by the transformation ratio of this transformer, that will be 11 divided by 121. 11 divided by 121 into what is the V2 base value? It is 22 into 11. So that 11, 11 and 121 will be cancelled. So that you will get 22 kilovolts. 22 kilovolts is the correct answer. So let me check how many students have given the answer. Option C. Very good, very good, very good, very good. So Anita, aspirant and Anita, Uma. So everybody is given the perfect answer. That will be 22 kilovolts. 22 kilovolts. See here? So like that we can solve the problems in the per unit system, students. Right. So we'll go for the next question here. Right. So this question is based on the bus admittance matrix and bus impedance matrix. Which of the following statements about Y bus and Z bus are not correct? Which of the following statements about Y bus and Z bus are not correct? They are asking which are not correct. Try to give the answer. The statements they are given. Y bus gives the direct interconnectivity between the buses, and Z bus will not give. Z bus will not give. And second one is given Yij is equivalent to minus 1 by Zij, and Yii is equivalent to 1 by Zii, and Z bus is full matrix and Y bus is sparse. So any answer? Any answer from this one? Try to give the answer. Try to give the answer. What is the correct? Which is not correct? Which is not correct? They are asking which is not correct statement. Try to check it. Y bus gives the direct interconnectivity between the buses and Z bus will not give. Is the statement correct? Yes, that statement will be correct statement. Y bus gives the direct interconnectivity between the buses and Z bus will not give. So it is this statement is correct, and they are asking not correct statement, so that it is not the correct answer for this question. And what about Yij is equivalent to minus 1 by Zij? So that if you want to calculate Yij, suppose Y12, capital Y12, if you want to calculate, that will be, you have to calculate negative of minus small y12. If you check here, capital Y12 is negative of minus small y12. What is small y12, students? It is 1 by Z12. Therefore, capital Y12 is minus of 1 by Z12. Capital Y12 is negative of 1 by Z12. This statement is also correct, and it is not the correct statement for the given question, right? And what about Yii? If you want to calculate Yii, what is Yii? Addition of all the admittances connected to that bus. Addition of all the admittances connected to that bus, and that will not be the inverse of that one. This statement is wrong, and it is the correct answer, right? And Z bus is full matrix, and whereas Y bus is sparse matrix. This statement is correct, and it is not the correct one. So that if you want to calculate Yii element, inverse of Zii is not true. Inverse of Zii is not true, right? Yii is addition of all the admittances connected to that bus. So one statement you can understand here, students. Y bus is the inverse of Z bus. That's true. That's true. But don't try to calculate individual element inverses. Individual element inverse is not true. That means Yii is not the inverse of Zii. Clear, students? I think it's clear for you. So try to understand. Try to understand. So nobody is given the answer. Nobody has given the answer. You can check. You can cross check by taking some Y bus values and Z bus values. So Yii element is not the is equivalent to 1 by Zii. Clear, students? So please respond, everybody. Please respond, everybody. Right, students. So I am changing the next question here. So please check it. I am going for the next question. So here Y bus is Z bus overall. If you want to calculate Y bus, overall Z bus inverse only. Perfect. Don't try to go for individual element inverse. Individual element inverse. Clear, right? Right. So next one. The voltages of a generator and an infinite bus are given as 0.92 at an angle of 10 degrees and 1.0 at an angle of 20 degrees respectively. Which of the following statement is correct? So first one is given, the active power flows from generator to infinite bus and reactive power flows from infinite bus to generator. And second one is given, active power and reactive power both are flowing from generator to infinite bus. And third one is given, reactive power flows from generator to infinite bus and active power flows from infinite bus to generator. And option D, active power and reactive power flows from infinite bus to generator. Any answer? Any answer? So try to give the answers. Try to read the statements clearly. Try to read the statements clearly. They are given, generator voltage is given 0.92 at an angle of 10 degrees and the infinite bus voltage is given 1.0 at an angle of 20 degrees. Then which of the following statements are correct? Any answers? Durga Prasad, Anita, Uma, aspirant, Jagtap, any answers? Any answers? Shall we expect? No response? Right, students. So I will give the answer. Please check it. in every power system network, whenever it is reactive, please check here students. In a power system network, suppose if you are having a generator here and in between we are having the reactance. If you are having one more machine here. These are the two machines connected here. This is machine 1. This is machine 1 and this is machine 2. Right? Suppose machine 1 voltage is V1 at an angle of delta 1. Machine 2 voltage is V2 at an angle of delta 2. The line reactance of J times of XL. So in this system, the active power is nothing but V1 V2 divided by XL into sine of delta 1 minus delta 2. Sine of delta 1 minus delta 2. From this equation, we can say that the active power is proportional to sine of delta 1 minus delta 2. So which can be called as proportional to delta 1 minus delta 2. The active power is always proportional to delta 1 minus delta 2. Therefore, in a reactive network, the active power P is proportional to delta 1 minus delta 2. Therefore, when delta 1 is greater than delta 2, the active power will become positive, so that it is flowing from bus 1 to bus 2. When delta 2 is greater than delta 1, the active power will become negative and it is flowing from mission 2 to mission 1. Clear, right? Therefore, we can give a clear-cut statement that in a reactive network, the active power always flows from high value of delta to the low value of delta. That means the in-between reactance should be inductive reactance, then only the active power always flows from high value of delta to the low value of delta. Right? So high delta to low delta. Active power always flows from high delta or high voltage phase angle, high delta to low delta or low voltage phase angle. You can check the question here. What is the question they have given? Here, so here it is given 10 degrees and here it is given 20 degrees. So it is infinite bus voltage and it is generator voltage. The active power is flowing from 20 degrees to 10 degrees. So that the active power is flowing from infinite bus to the generator. The active power is flowing from infinite bus to the generator. You can see. So active power flows from generator to infinite bus. Right? That's not correct statement. So reactive power flows from generator to infinite bus and active power flows from infinite bus to the generator. So active power is flowing from infinite bus to the generator. One statement is clear. We will check about the reactive power also. So if you see about the reactive power in every power system network is proportional to magnitude of V1 minus magnitude of V2. When V1 is more than that of V2, Q will be positive. It is flowing from mission 1 to mission 2. When V2 is more than that of V1, then reactive power is flowing from mission 2 to mission 1. Therefore, we can say the reactive power in an inductive reactance network, we can say it is always flowing from high value of voltage magnitude to the low value of voltage magnitude. Right? So in a inductive reactive power network, what happens? The reactive power always flows from high value of voltage magnitude to the low value of voltage magnitude. And I can check here. So where you are having, so this is 1 and it is 0.92. Therefore, the reactive power is also flowing from mission 1, that is infinite bus to the generator. We can write. So both active power and reactive power flows from infinite bus to the generator. Both active power and reactive power are flowing from infinite bus to the generator. So we will see how many students are given the answer. Let me check how many students have given the answer. Right. Yes, very good. Yes, very good. Active power flows from high load angle to the low load angle. Very good. Yes, very good. Yes, P depends on load angle. Yes, Q depends on voltage. Yes, Right. Right. Right, students. Right. Thank you, Suresh Reddy. Right. So see here, students, is it clear? Is it clear? So active power more depends on delta, reactive power more depends on voltage. I think we have studied already that one in the decoupled equations, right? Active power is always proportional to delta or change in delta. The reactive power always proportional to change in voltage magnitude. Voltage magnitude. So active power is more sensitive to delta variation and active power is less sensitive to voltage variation. Reactive power is more sensitive to voltage variations and it is less sensitive to delta variations. Clear? It is clear, I think, right? We'll go for the next question, students. See here, consider the following table below for different types of buses where each set may consisting of any parameters V. V is any set of parameters. V is the voltage magnitude, P is the real power injection, Q is the reactive power injection and delta is the phase angle. Then what are the specified and not specified quantities? Load bus is given, what are specified quantities and what are quantities to be obtained from the bus. And slack bus, generator bus, load bus all are given, set A, set D, B, E, C, F. And they are asking that, the question is, in that A and E are same but C and D are different. And B and F are same but C and D are different. C and D are same and A and F are different and C and D are same but D and B are different. See here, first of all write which are same and which are different. Which are same and which are different. So we know. So just I can expect this answer from many students. Any answer? Any answer? You can type your answer there. You can type your answer there. Any answers? Any answers? Durga Prasad, Uma, Monica, Jagtap, Anita, Reddy, aspirant, right? So Naresh Kumar, thought Naresh Kumar given C, option C, right? We'll see. What is option C? Option C is given, set C and D are same but A and F are different. He is saying that C and D are same and A and F are different. Just check here, I will write what are the known quantities. For load bus, which are known quantities? Which are quantities are specified for load bus? For load bus, P and Q are specified. P and Q are specified. Which quantity should be obtained? V and delta. Magnitude of V and delta should be obtained. For slack bus, which quantities are specified for slack bus? For slack bus, the quantities specified are V and delta, and which are obtained? P and Q. P and Q should be obtained for the slack bus. For generator bus, which are specified? It is also called as PV bus. P and magnitude of V are specified. Which should be obtained? Obtained should be delta and Q. Delta and Q should be obtained. You can say A and E are same. A and E are same. Do you have any option like that? A and E. A and E are same. A and E are same. And C and D are same. C and D. What about C and D? C and D. C and D are not same. A and E are same. A and E are same. And C and D. What about C and D? C and D. Yes, C and D are different. Yes, right? So that we can go for option A. We can go for option A. Please check it. Please check it. Anybody given? Yes, aspirant given. Yes. Yes. Durga Prasad Chari. Yes. Very good. So that based on that one, you can give the option. So Naresh Kumar, please check it. Monica, please check it. Anita. So is it clear, everybody? Is it clear, everybody? It's one of the easiest question based on the quantities specified. Quantities specified. Clear, right? So we are going for the next question. Next question. The accelerated value in case of Gauss-Seidel load flow method by using acceleration factor alpha is. What is the accelerated value in case of Gauss-Seidel load flow method by using acceleration factor alpha? Right? So you can see here, if you want to calculate Vi of r plus 1 for accelerated value, the accelerated value, if you want to calculate, take r plus 1th iteration, minus the rth iteration, multiply that one with the accelerating factor alpha, and that should be added to the that should be added to the previous iteration value. That should be added to the previous iteration value. Please check it where you are having that one. Where you are having this one. So it is in which option? It is in which option? Please check it. It is in which option? Option B. Option B. So we'll see how many students have given this one. Yes. Option B, perfect. And yes. He is giving the answer. Durga Prasad Chari. He is giving the answer value 1.6. Here the value of alpha ranges from 1.2 less than alpha less than 1.6. That is the range of alpha. Actually, that will be varying from one system to the other system. But whenever nothing is specified, we can fix that value to 1.2 to 1.6 actually. Right? So that this is the accelerated value for r plus 1th iteration. Clear, students? In case of Gauss-Seidel load flow method. Next one. A power system consisting of 262 buses, out of which 21 buses are connected with generators, 17 buses are connected with the voltage control, with reactive power support, and 22 buses are ones with the fixed shunt capacitors, and all other buses are load buses. It is proposed to perform load flow analysis by using Newton-Raphson method. The number of non-linear algebraic equations to be solved are. How many number of equations you have to solve? Try to solve that one. Any answer? Try to solve this. It is one of the famous question asking from a lot of time, right? So here they have given the total number of buses. We can take it as n. It will be 262. In which they are saying that 21 buses are connected with the generators, and there is no information given about the slack bus. So that number of generators, how many they have given? It should be 21 they have given. In this 21, remove 1. This 1 is for slack bus. So that how many generators are there? 20 generators are there. So that in the given from the given data, so one of the slack bus, that means slack bus should be one of the generator bus. So in the given 21 generator bus, so one should be taken, so that remaining generator buses are 20. But how many number of total PV buses are there? Total PV buses must be number of generator buses plus number of reactive power support buses. So total PV buses, we can denote with M. What is that? M is equivalent to number of generator buses plus number of reactive power support buses. Reactive power support buses are 17. How many it will be? 37. 37 are the reactive power support buses. And fixed shunt capacitor buses, the reactive power will be fixed. When reactive power is fixed, they can be considered as when reactive power is known, we can consider them as PQ buses. So that these fixed shunt capacitor buses, these 22 buses are PQ buses. Tell me how many number of total PQ buses? It will be How many is equivalent to? It will be total number of buses are 262 minus 37 are the PV buses minus 1 is the slack bus. Minus 1 is the slack bus. How many it will be? 262 minus 37 minus 1. 262 minus 37 minus 1. 486. You got it as 486. Option C. What is the answer? 262 minus 37 minus 1. Good evening Amla. What is this one? What is 262 minus 37 minus 1, students? 230. 262 minus 37 minus 1. Is it 224? Is it 224? Yes. Is it 224? The number of PQ buses will be 224. The number of PQ buses will be 224. Tell me, number of equations to be solved. Number of equations to be solved. How many number of equations you have to solve? Number of known active power equations and number of known reactive power equations. This will be number of known P equations plus number of known Q equations. How many number of P equations will be there? How many number of P equations will be there? The number of P equations. So at how many buses P will be known? At how many buses P will be known? Every bus except at the slack bus. Every bus except at the slack bus. So that total number of buses are 262 except at slack bus. At every bus it is known. So that 261 buses. At 261 buses active power is known, plus at how many buses Qs are known? Qs are known only at the PQ buses. How many number of PQ buses are there? The number of PQ buses are only 224. 224. So how many it will be? 485 is the answer. 485 is the answer. Very good. Aspirant is given, it is 485. Please check it, students. The number of known P equations and number of known Q equation. The number of known P's are at every bus P is known except at the slack bus. At all PV buses, at all PQ buses, active power P is known except at the slack bus. Therefore, we can write. So that if you check here, these are PV buses. At all these buses, P is known. At 224 buses, there are PQ, so P is known. Only at the slack bus, P is unknown. Therefore, we have to add that one. At how many buses Qs are known? At all PQ buses. Only at PQ buses Q will be known. So that add that. How many PQ buses are there? 224. So that add that 224. So total will be 485. 485. Anita is given now. Very good. Is it clear, everybody? I think it's clear. Right. So we'll go for the next question now. Right. See here. So this is the question given, students. The Newton-Raphson formulation is given by del P del Q is equivalent to H N M L multiplied with del delta and del mod V. The angular stability of the power system network will be given by which of the following Jacobian element? So which element? So this is the Jacobian matrix we are having. In this Jacobian matrix, which element will give you the angular stability information? The angular stability information will be given by which element? Any answers? Which element will give you the information related to the angular stability? Any answers? You can check here. They are given del P del Q is equivalent to H N M L multiplied with del delta del mod V. They are given. Del delta and del mod V. They are given. Tell me, what is H? H is mapping P and delta. Therefore, the H is mapping between del P divided by del delta. which is nothing but dP by d delta. The variation of active power with respect to delta is called as the angular stability. The angular stability. So that the angular stability will be given by the parameter h. What is n? N is mapping between P and V. Del P divided by del mod V. Del P divided by del mod V. We have already told active power variation with respect to voltage is very small and it can be neglected for some times. In case of decoupled and fast decoupled load flow method, we are going to neglect this n value and we are substituting this n value as 0. In case of decoupled and fast decoupled. Why? Because the variation of active power with respect to voltage is very small. Active power is more sensitive to delta variation. Active power variation with respect to voltage will be very small and we can take it as 0. And what is M is mapping between? M maps between Q and delta. Del Q divided by del delta. I already told you reactive power is more sensitive to voltage variation, not for the delta variation. So that del Q divided by del delta is also very small and can be neglected for decoupled and fast decoupled load flow methods. Therefore, you can neglect the value of M also, the variation of Q with respect to delta. And what about L? L is mapping between Q and V. It is del Q divided by del mod V. The variation of reactive power with respect to variation of voltage. So, it is giving the voltage stability information. Voltage stability information. Therefore, so parameter H gives the information about rotor angular stability and L gives about the voltage stability of the power system network. Power system network. Yes. Angular stability. So variation of active power with respect to delta should be positive. Very good, very good. Durga Prasad. Whenever so del P by del delta is positive, then only the system will be stable. If it is not positive, then the system will not be stable, right? So that information will be given by H. I am saying the information will be given by H. So we have to decide whether it is positive or not, and finally we have to give, right? So that what is the correct answer, students? What is the correct answer? H is the correct answer. Yes, aspirant, very good. Reactive power variations with respect to delta are ignored for decoupled and fast decoupled load flow method. So there we are considering high X by R ratio systems. Because of that approximations we are going to take. So given Haima given H, very good. Durga Prasad, yes, very good. Answer is option A. Clear, students? So we'll go for the next question here. Try to solve the next question. The number of equations to be solved is less in one iteration in case of. In which case the number of equations to be solved are less. First one is Gauss-Seidel method. Second one is Newton-Raphson method, polar coordinates. Third one is Newton-Raphson method, rectangular coordinates. And the last one is fast decoupled load flow method. In which case the number of equations to be solved are less. In which case the number of equations to be solved are less. Any answer? Aspirant are Durga Prasad, Naresh, Haima, Anita, Naresh, Uma. Any answer? Any answer? Option C. NR method rectangular coordinates. NR method rectangular coordinates, that will be lesser. The number of equations to be solved. Option D. Fast decoupled load flow method. Fast decoupled load flow method. Thota Naresh Kumar. Given option C. Aspirant given it is option A. Gauss-Seidel load flow method. Gauss-Seidel load flow method. Yes. Anita given it is option A. Haima given it is option B. Please check it, students. The number of equations to be solved in one iteration. The number of equations to be solved in one iteration. Number of equations to be solved in one iteration. One iteration. First one, Gauss-Seidel method. in case of Gauss-Seidel method, we are going to write equations at every bus except at the slack bus, right? That Gauss-Seidel load flow equation, magnitude of V at an angle of delta equation, we are going to write for every bus except at the slack bus. So that how many equations you have to solve? That will be n minus 1, total number of buses minus slack bus. That means it will be n minus 1. And whereas in case of NR method polar coordinates, NR polar coordinates, it will be 2n minus m minus 2, 2n minus m minus 2, where m are the number of PV buses, where m are the number of PV buses. And in case of NR rectangular, it will be 2n minus 2, 2n minus 2, right? Now for example, if n is equivalent to 100, then number of equations to be solved in case of GS method, it will be 99. Suppose if you are having m is equivalent to some 10 buses, right? How many equations you have to solve here? 200 minus 12, 200 minus 10, it will be 190, 190 minus 2, it will be 188 equations. 188 equations you have to solve in one iteration in GS polar method. In NR rectangular method, it will be 2n minus 2, it will be 198 equations you have to solve. So highest number of equations to be solved in NR rectangular method and least number of equations to be solved in GS method. Therefore, for one iteration, the time taken by GS method will be very small for one iteration. But that number of iterations are large in number. But whereas the Gauss-Seidel method, whereas the Newton-Raphson load flow method, particularly in polar coordinates, will give the convergence in less number of iterations, approximately 4 to 5 number of iterations it is going to give. But whereas the Gauss-Seidel method will take large number of iterations to give the solution. Clear everybody? So the correct answer is option A. Yes. So Upender, very good. And Damani and Haima. Yes. It will be option A. The Gauss-Seidel load flow method is the perfect answer. Gauss-Seidel load flow method is the perfect answer. Suppose if the same question asked for the number of equations to be solved will be highest in one iteration. For which one? The number of equations to be solved will be highest, the maximum. If the same question asked for will be maximum for which of the following method? It is option A, highest, I am saying. Yes. Dilip Satya. Tell me, highest possible number of equations to be solved in one iteration. Where you are solving that one? Yes. That will be in Newton-Raphson method polar coordinates. NR method polar coordinates. Convergence time. See your students. In case of GS method, the overall time of convergence will be very high. In case of GS method, the overall time of convergence will be very high. So it is taking high time for the convergence, and whereas NR polar method, right? So we are having NR polar and NR rectangular. We are not going to consider NR rectangular. Why? Because it is going to take more number of equations to solve in one iteration. So that for us, Newton-Raphson method means it is NR polar coordinates only. We are not going to consider NR rectangular coordinates method. Clear, right? Why? Because we need to solve more number of equations in one iteration. So that compared to Gauss-Seidel method, the Newton-Raphson load flow method will take less time for the convergence. And in case of fast decoupled method, the number of equations that you are going to solve are approximately close to the Newton-Raphson method, but the time for convergence, the overall time for convergence is very less in case of the fast decoupled load flow method. Why? Because we are taking more number of approximations, and the Jacobian matrix inverse we no need to calculate. Why? In case of decoupled load flow method, we are making the Jacobian matrix as a constant matrix, so that for each iteration no need to inverse that. So that the time for the inversing Jacobian matrix has been reduced in case of the fast decoupled load flow method, the overall time for giving convergence will be very less in case of the fast decoupled load flow method. Here it is very less, here you have moderate, and it is very high time for overall convergence. Clear, students? Very good, very good. Right. Next question. See the next question. Which of the following load flow method is having linear convergence characteristics? Which of the following method is having the linear convergence characteristics? Linear convergence characteristics. Any answers? Any answers, students? Which of the following load flow method is having the linear convergence characteristics? Right. The linear convergence characteristics. Gauss-Seidel load flow method is having linear convergence, and Newton-Raphson method is having quadratic convergence, and fast decoupled and decoupled load flow methods are having the geometric convergence. Clear? So that's option A. Very good. Aspirant is given option A. So Gauss-Seidel method is having linear convergence, and the Newton-Raphson method is having the quadratic convergence, and the fast decoupled load flow method is having the quadratic convergence. Right, students? So these are the questions we have taken from the load flow analysis. Now we'll go for the next question here. What is the phase sequence of the given system? What is the phase sequence of the given system? Right, very good, Haima, Damini and Anita, aspirant. What is the phase sequence of the given system? Is it ABC or CAB or BAC or CBA? What is the phase sequence of given system? Any answer? ACB. But given from the given options, Uma, you have to give from the given options. Option C, BAC. Praveen Kumar, option D. Dilip Satya, option D. CBA. Very good. Right. I will explain. See here, how to give the phase sequence. Suppose, students, every time it may be positive phase sequence or negative phase sequence, represent them in the anti-clockwise rotation only. Actually, positive sequence will rotate in anti-clockwise direction and negative sequence will rotate in the clockwise direction. But to have uniformity between positive sequence and negative sequence, every time we are representing the quantities in the anti-clockwise direction. If it is A phase, suppose if it is B phase, suppose if it is C phase, assume that a person is standing here and he is looking in this direction. So that whenever he is standing here, A comes first, B comes next and C comes here, so that ABC is the phase sequence seen by him. ABC. Suppose if the same person is standing here, and he is looking like this, then what happens? B comes first and then C comes next and then A comes here. Here it is, BCA is the phase sequence. And if the same person is standing here and if he is looking like this, C comes first and A comes next and then B. So that ABC, BCA and CAB all are same. ABC, BAC, BCA, ABC, B comes here, C comes here. ABC and CAB both are same. ABC, CAB both are same. Right? Next one. Suppose we are rotating anti-clockwise also in the reverse direction. See here, it is rotating in anti-clockwise direction. It is also rotating in anti-clockwise direction. It is also rotating in the anti-clockwise direction. Suppose if the person is standing here and he is looking like this. C comes first and then B and then A, CBA. So that CBA is the perfect answer. Suppose if the same person is standing here, if he is looking like this, B comes first, B comes first, and A comes next, and then C, so that BAC is also the perfect answer. BAC is also the perfect answer, right? So ABC is not correct, CAB is not correct. So that either answer should be BAC, either answer should be CBA. Any one can be given, right? Both will not be given, any one can be given based on the situation. Clear, right? So that C is also correct, D is also correct here. C is also correct and D is also correct. So based on the reference, students, you have to check the reference quantity, right? What is the reference quantity? Suppose if A phase is reference, it will be ABC. If B phase is reference, it will be BCA. If C phase is reference, it will be CAB. Suppose if it is C phase is reference, it will be CBA. If B phase is reference, it will be BAC. If A phase is reference, it will be ACB. Clear, everybody? So those who has given C and D, both are correct. CBA or BAC. Please check it, is it clear or not? Please check it, students, is it clear or not? Respond, everybody. So I am going for the next question. So try to understand the phase sequence based on the reference quantities. So it depends on the reference quantity. So when A phase is reference, ABC. When A phase is reference, ACB. Clear, everybody? Right. Next question. In an unbalanced star connected load, the phase voltages are given 1 at an angle of 0, 2 at an angle of 0 and 3 at an angle of 0. Then they are asking, what about the sum of the line components of the voltages? What about the sum of the line components of the voltages? The unbalanced voltages are given phase voltage. VA is given, VB is given, VC is given. These are the phase voltages in a unbalanced system. Then what about the sum of the line components of the voltage? Sum of the line components of the voltages. Can you tell me the answer? Can you tell me the answer? What is the answer for this one? Durga Prasad, Upender, Anand, Uma, Anita, Dilip, Satya, Praveen Kumar, very good, you are responding very fast, right? Anita, Haima, Damini, very good aspirant, Naik, Naresh Kumar. What is the answer? Option B. VAB plus VBC plus VCA is greater than 0. Na? Praveen Kumar given it is option B. Any other answers? Any other answers? Option A, aspirant, you are every time perfect. Haima, it is option B. It is option B. Now check here, students. The sum of the voltages VAB. What is the formula to calculate VAB, students? The line voltage. VAB is equivalent to VAN minus VBN and VBC is equivalent to VBN minus VCN and VCA is equivalent to VCN minus VAN are the formulas to calculate. Whenever you are adding them, VAB plus VBC plus VCA, it will be equivalent to plus VAN minus VAN will be cancelled, minus VBN plus VBN will be cancelled, minus VCN plus VCN will be cancelled, so that it will be equivalent to 0. So that the sum of line components of a voltages in a star connected system is always 0 whether the system is balanced or unbalanced. No need to check it. But if you want to make the sum of the phase voltages equivalent to 0, the system should be balanced. The system should be balanced. I will write the statement here, try to understand. In a star connected system, the sum of line voltages, VAB plus VBC plus VCA is equivalent to 0 always when system is balanced or unbalanced. When system is balanced or unbalanced. But the sum of the phase voltages VAN plus VBN plus VCN is equivalent to 0 only when system is balanced. Only when system is balanced. Only when the system is balanced. So take any random values for VAN plus VBN plus VCN, then sum of VAB plus VBC plus VCA is equivalent to 0, right? So this condition is valid only whenever you are fixing VAN, VBN, VCN values and you are calculating VAB, VBC, VCA values. And if you are fixing VAB, VBC, VCA directly, sir, I will take VAB is 1, VBC is 1, VCA is 1, means it will not be 0. It will not be 0. What I am saying is, whenever you are fixing the phase voltage and if you are calculating the line voltage, then these conditions are valid. Clear, students? I think it is clear for you, right? So please check it. Please check it, right? So this is the condition we are having, right? So that, what is the correct answer? The first option, option A is the perfect answer. Option A is the perfect answer. Likita, so please check it. Option A is the perfect answer. Very good, very good. So Dilip Satya, very good, right. Next question. Tell me, students, which of the following faults can be simulated for a solidly grounded unloaded alternator with all three sequence networks? With all three sequence networks. Which of the following faults can be simulated for a solidly grounded unloaded alternator with all three sequence networks? All three sequence networks are required for which of the following faults? Positive sequence, negative sequence and zero sequence networks are required to analyze which of the following faults. Very simple question only, na? You need to give the answer, the students. So which of the following faults can be analyzed with all the three sequence networks, positive, negative and zero sequence networks? So that very good aspirant, that will be LG and LLG faults. Very good, very good. LG and LLG faults, right? So for LG and LLG faults, all the three sequence networks are required. For LL fault, zero sequence network is not required. For triple L fault, only positive sequence required network is required, no, not required. That is zero sequence and negative sequence networks are not required. Very good, very good. Haima, Anita, Uma, Prasad and Upender. Very good. Tell me, students, the relation of sequence voltages for a three-phase fault. What is the relation of sequence voltage for a three-phase fault? Right, right. Megawatt Nide, very good. What is the relation of sequence voltage for a three-phase fault? For this question, what is the answer? For this question, what is the relation of sequence voltage for a three-phase fault? Any answer? VA1 is equivalent to VA2 is equivalent to VA0 is not is equivalent to 0, right? Harshavardhan Sai, CC, very good, very good, very good, very good. All are 0, very good, all are 0. For a three-phase fault, all the sequence voltage components are 0. Dilip Satya, please check it, please check it. For three-phase fault, all are 0. Positive sequence voltage, negative sequence voltage and zero sequence voltage are all are 0 for a three-phase fault. Three-phase fault. Very good everybody. Next question. A 220 kV transmission, it's a very common question we are getting. So a 220 kV transmission line is fully transposed. Then the valid positive, negative and zero sequence impedances without mutual impedances will be respectively. What are the positive, negative and zero sequence impedances without mutual impedances will be respectively? What are the positive, negative and zero sequence impedances without mutual impedances will be respectively? Aspirant given option A. First time aspirant is given wrong answer. So now everybody is giving wrong answer. See here, students, what is Z1? Which is ZS minus ZM. ZS minus ZM. Is it right? What about Z2? ZS minus ZM. What about Z naught? Zs plus 2Zm. They are saying Zm is 0. They are saying Zm is 0. When Zm is 0, you have to give the answer. Please check it everybody. Meghavat Naidu. When Zm is 0, the network is not having any mutual impedances. When mutual impedances are not there, Z1 is same, Z2, Z0, all are same. Z1 is equivalent to Z2 is equivalent to Z0. All are same. Please check it. So small mistake you can give will lose 1 mark. Clear? Read the question carefully. They are given that without mutual impedances. So then all should be same. When mutual impedance are existed, then it will be 0.1, 0.1, 0.3. That will be perfect. Whatever you are giving, that will be giving. Clear, students? They are asking this question without mutual impedances. Clear, right? Next question. 2 power stations A and B. 2 power stations A and B with inertia constants 10 seconds and 10 seconds are having power transfer between them. Now these are combined together, then the equivalent inertia constant will be, right? What is the equivalent inertia constant between them? What is the equivalent inertia constant? 2 power stations A and B with inertia constant 10 seconds and 10 seconds having power transfer between them. So Dilip Satya given it is 15. Now these are combined together, then equivalent inertia constant will be option B, 5 seconds. So aspirant is given B. Naik is also given B. Clear? See here students, power transfer is proportional to delta 1 minus delta 2. Is it right? This equation is very clear for you. Power transfer is proportional to delta 1 minus delta 2. When delta 1 is exactly equivalent to delta 2, then the machines are swinging together. We already told. When delta 1 is exactly equivalent to delta 2, then the machines are swinging together. When delta 1 is equivalent to delta 2, the machines are swinging together means the power transfer between those two machines will be 0. We can say that when delta 1 is equivalent to delta 2, power is 0, so that the machines will not have any power transfer between them. They are said to be swinging together. And they are saying that the 2 power stations A and B with 10 seconds, they are having power transfer between them. They are existing the power transfer, which means that P is not 0, which means that delta 1 is not equivalent to delta 2. Then P is not equivalent to 0. So that when delta 1 is not equivalent to delta 2, the machines are said to be not swinging together. Clear, right? So when machines are not swinging together, what is the equivalent inertia constant? H equivalent is nothing but H1 H2 divided by H1 plus H2. It will be 5. So when both are having 10, it will be 5. So Meghavat Naidu, Rahul, please check it. It will be 5. It is not 20. Clear, everybody? So please think what I have given. So I told you already. So whenever the machines are swinging together, delta 1 should be equivalent to delta 2. So when delta 1 is equivalent to delta 2, P should be 0. There is no power transfer between the machines. But whenever, yes, non-coherent operation only, non-swinging, not swinging or non-coherent operation. Very good. Clear. Right. Now tell me, according to equal area criteria of the power system stability analysis, the condition for the stability is, what is the condition for the stability? According to equal area criterion of the power system stability analysis, the condition for the stability is, any answer? What is the condition for the stability of the power system network? Any answers? dP by d delta is equivalent to 0, or d delta by dt is equivalent to 0, or accelerating power PA should be positive and accelerating power PA should be negative. Aspirant, you are going PA should be positive. When accelerating power is positive, the rotor gets acceleration. When rotor is accelerating, can I say the system is stable? No. Durga Prasad is given option B. Option B is the perfect answer, right? The variation of delta with respect to time should be 0, so that the delta should be constant. Whenever delta is constant, then we can say the system is stable. Whenever delta is constant, the system will be stable. According to equal area criterion, it says that the variation of delta with respect to time should be 0, so that there is no increment in delta or there is no decrement in delta, it should be constant. Clear everybody? Clear everybody? Right. So these are the questions we have taken. These are the questions we have taken. Very good, Megawat Naidu. Right, students? So I think the questions and the concepts are very clear for you. So prepare well. All the best for your preparation and all the best for your examinations, students. Right? So thank you everybody. Thank you for responding. And the concepts are very clear, I think so. Right.